This question asks about investigation. We investigate the motion of a trolley. The trolley travels, here's the trolley, and it's traveling down the slope at uniform acceleration. Runway, here's the runway that the trolley is traveling on. It's set up as shown. And we need to answer these questions. Give a reason why the slope of the runway has to be adjusted. So it says the slope of the runway is adjusted before readings are taken. And that's because we need uniform acceleration. So we need to make sure that it's steep enough that we're not only just overcoming friction. If we only just overcome friction, we'll get uniform velocity. So we need to compensate for friction, and then we also need to give some more angle than that so that we get acceleration as well. The ticker tape is analyzed, and the displacement, the change in position, delta x, is measured after each 0,2 seconds. So actually we could extend this, and what's not written there but is implied is delta x. We calculate how much has the displacement been during that interval. 0 to 0,2 is 0,2, and then for that next interval 0,6 minus 0,2 is 0,4, and then 1,2 minus 0,6, 0,6. Then we have 2 minus 1,2, 0,8. 3 minus 2, 1. So each of these intervals that we're referring to here, each delta t is 0,2 seconds. So 0,2 seconds passes during this interval, 0,2 second passes during that interval, during that, and during that. And what we really want to see is, how does the passing of time affect the displacement undergone in that time interval? So the independent variable is the time. It's independent of us, or independent of the setup of the equipment. And so it's independent of our position and therefore our delta x, our displacement readings. And then the dependent variable is displacement, in other words, change in position, delta x. Because we want to see how this changes. How far they go per interval of time change as time passes. Now we need to draw a graph of this data. So it's position time data, it's this data here, not that data there. So this is what you should draw. Make sure that you meet all these criteria for your graph. So you need to have a suitable heading, something like position time graph for the trolley traveling at uniform acceleration. You need correct labels on both axes. So you need time and then the unit seconds, position and its unit meters. We need an appropriate scale. So this must be a uniform scale, and so must that. You see it goes up in regular intervals of 0,2 seconds. And here this one goes up in 0,5 seconds. And it's an appropriate scale because it starts at 0 and ends at the maximum value, 3 in the data. And this one also ends at the maximum value, 1. So it's a good scale, it's spread out nicely, and it's uniform. And then all 6 points must be plotted correctly. So make sure that you do read off correctly from the table and plot them right, and then join them with this curve. And then we're asked what type of motion. Is it uniform motion, also called uniform velocity, or is it uniform accelerated motion? And to see that, we need to put in again what I've rubbed out previously, which is the change in position, the displacement for each of these delta t intervals of 0,2 seconds. So for every one it's 0,2 seconds. But let's work out here. Again, we have 0,20, and for this interval 0,6 minus 0,2, 0,4. For this interval we have 0,6 displacement. For this interval 0,8, and for this interval 1. So we can see it on the graph as well. For this interval here, which is this first 0,2 seconds, the displacement was 0,2. meters over here. And then for the next 0,2 second, the displacement was now more. It was 0,4 meters. And then for this 0,2 seconds, the displacement is 0,6 meters. And then for this next 0,2 seconds, the displacement now is 0,8 meters. And for this 0,2 second interval, the displacement is 1 meter. So we can see that in successive time intervals, the trolley moves further and further, and always a uniform amount further, always 0.2 further than it did in the previous one. So we can see from that it must be accelerated motion, well, to be exact, uniform accelerated motion, because the rate of increase of velocity is constant. Acceleration is the rate of change of velocity. And so if we have uniform acceleration, then the velocity changes a constant amount, so constant change per delta t. Of course, I don't need to write that change because there's the change. Change in velocity is constant per delta t. We haven't actually worked out change in velocity here, but velocity per time is just got from dividing that by that, or getting the gradient of each part of the graph. Of course, the graph is curving. But we have uniform accelerated motion. How can we see that? Because the graph curves regularly upward. Another way of saying that, or another way of justifying that we've got uniform accelerated motion, is that the displacement increases regularly, always by another 0,2 meters per time interval, per delta t, in other words per 0,2 seconds. Delta t in this case we use as 0,2 seconds.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!